Today we're taking a look at section 12.3 on measures of dispersion, sometimes referred to as measures of variation. And my question is, what information do the measures of center not give us? And to give you an idea of what the measures of center do give us some information, but what they don't tell us, we're going to look at an example. When I first started Germana, my office was at Locust Grove because there was no Fredericksburg campus. And I came in for 1 week during the winter, and I recorded the temperature in my office each day when I arrived. So if I told you that the mean temperature for that week, so I'm saying I'm actually working with a sample, just a week's worth of temperatures. If I tell you my mean temperature at the office each day that week was 72 degrees, would you think that my office was a comfortable place to work? So if we're thinking about 72 degrees, that sounds like that would be pretty comfortable. But actually, here are the 5 temperatures. At that time, we didn't have classes on the weekend, and so the heat was turned off in the entire weekend. And so when I came in to my office on Monday morning, the temperature was 52 degrees. And of course, we complained about the temperature, so they would finally turn the heat on. And by Tuesday, the temperature had made it up to 65 degrees. Now, by Wednesday, the heat was working pretty well. It had finally made it up to 71. Then it was really cranking out, doing quite well. So it was finally Thursday, late in the day, it got up to about 86. And of course, we started hollering and complaining about the heat. And so by Friday, they finally listened to us and turned it back or off for the weekend. So what I want you to do now, you have the 5 temperatures I recorded for that week. From these 5 temperatures, figure out the mean, the median, the mode, and the mid-range. So pause the recording, figure those out, and then start it back up. Okay, I'm assuming that if you've restarted this recording that you have figured out an answer. And so the mean, if we add up all the values, I believe we get 360. Let's see, 7, 8 plus 12 would be 20. Let's see, 7's 14, 20. Plus 16 is 360. Okay, so 360 divided by the 5 gives us 72 degrees for the mean. The median is the middle one. These are in numerical order, so that would be 71 degrees. The mode is the most frequent. And the mid-range is 86 plus 52 divided by 2. So that would be an 8. 138 divided by 2, which would be 69 degrees. Okay. So as I look at these, 69 perhaps is a wee bit cool, but it's not that far off from 72, which I consider 71 and 72 to be very comfortable. 86 is very warm. That one might cause me pause for concern if I were looking at these measures of center. So basically we're seeing that the measures of center, other than the mode, are all relatively comfortable, these 3 right here. So those 3 are relatively comfortable. So the information that the measures of center are not giving me is the spread of the temperatures over that week. So what we do is we look at another measure, which is called the measure of dispersion or the measures of variation. And the first one is a relatively easy one to calculate. It's the range, and we just take the high value minus the low value. So in this case, 86 minus 52 would give us a range of 34 degrees. So that's really not too awfully bad. Okay, so we can see that that's not too bad to calculate, but if you think about a 34-degree temperature variation or a difference between the high and the low in an inside office, 34 degrees is quite a large variation. The second measure of center that we look at is what we call the standard deviation. Now, as you can see, we have two formulas, and let me get my pen back to. The first one is we take the difference between each value and the mean. We square that difference and then add it up. Remember, this means summation. We're adding those up. We divide by the number of values minus 1 and then take the square root. For the population standard deviation, again, we're going to take each data value minus the mean, square that difference, add those up, divide by the number of values. So we can see there's a slight difference in the formula for the population and the one for the sample. We're going to stick we're only going to talk about sample standard deviation. I wanted you to be aware that there was a population standard deviation formula and that it was slightly different from the one that we use for the sample standard deviation. So what I want to do now is use the table we have here to actually calculate the sample standard deviation for my office temperatures that week at Locust Grove. Okay, so our mean is 72 degrees, so 52 minus 72 is going to give us a negative 20. 65 minus the 72 is going to give us a negative 7. 71 minus 72 is a negative 1. 86 minus 72 is 14. And so that one's going to be a 14. So what we found is the deviation of each of the data values from the mean. This is the deviation in this column we're working in. Now, if I add these up the way they are, I'll get a 0. So that's the reason we go through the process of squaring and then taking the square root, so that all of the numbers become positive. We take a square root of that, and so we're finding the deviation whether it's positive or negative. So we're squaring each one of these now. According to the formula, we want to square them. Okay, 49, 1, and I think that's 256. Oops, whoops, I did 16 squared. It should be 14 squared. 196. I should have gone, that's what I had in my head. 196. Kept thinking that looks a little bit big. Okay, so according to the formula now, we want to sum them. So we want to add up this column we just did. We have 196 times 2 plus a 1 plus 49 plus 400. So I'm getting 842. So our standard deviation here is going to be the 842 that I just found divided by n minus 1. 1, 2, 3, 4, 5 values, so n is 5. We have 5 values. 5 minus 1 would give us a 4. Okay, so I want to divide that by 4. That's 210.5, and I want to take the square root of that. 210.5. Use the calculator for the part. And I'm getting a standard deviation of about 14.5, 14 and a half. So again, if we're thinking about temperatures in an interior room, a spread, an average spread or an average difference between the mean and each temperature value of 14.5 degrees is quite a bit. Now, in the textbook, they also talk about the variance. The variance is a square of the standard deviation. So if we look back at the office temperatures, the variance would be the square of this, and that's actually this number we have inside the radical or radicand. So this would be the variance. So this is the standard deviation, and this one's the variance. Okay, and let's see, 210.5. Let me put that in there. Okay, and when we calculate the standard deviation from a frequency table, I usually typically use a calculator for that. And I do want to show you how to do a couple of things on the TI-83. It'll show you how to do also the measures of center as well as the standard deviation. So I think we'll handle that in the next recording. I'll do one more recording to talk about the calculator part of this, and also Chebyshev's theorem in the next recording.